Good morning, everyone. Today we're going to talk about ratios and similar figures. I'm actually going to skip rates for this. And when we're doing this, we're going to need a few terms. You can see I've already started this one. So when you see F squiggly G, that does not mean we're just drawing random things. What it means is that our mathematicians are being a bit lazy again with writing things out. They decided that instead of writing F is similar to G, we're going to shorthand it with this little squiggly mark. You might find it somewhat familiar because we usually use this mark to say approximately equal to. This is saying they're similar to, they're alike, but they're not quite the same as. So just watch for that mark. That just means that these two figures are similar figures. And we know from before that similar figures are congruent in angle measure, or congruent in angles, so their angles will be equal. You can see that down here. This angle corresponds to this angle, and you can tell they're equal in measure. But their lengths are not going to be equal. Their lengths are going to be proportional. And that was what we had covered earlier as well. This one and this one are proportional to this one and this one. So if you compare them, they're going to have that same rate of change between them, and they're all going to be proportional to each other. And that's where ratio of similitude comes in. Now, ratio of similitude is best seen through example. So I could say that an object, like let's say F is similar to G. And let's say that their ratio of similitude is 3 to 2. Notice how I write this. I say 3 to 2, and that 2 is just this little colon here, okay? Now with this 3 to 2, what it's saying is that in F, anything that is 3 inches would have in G something that is 2 units. So 3 units to 2 units in length. So if this one had something that was 6 units, this second figure would have something that would be 4 units. It would still remain proportional, okay? So ratio of similitude is just that proportion that we write. We write it as 3:2, but you could also rewrite it to be a proportion very easily by just replacing the colon with a division sign. And you're actually allowed to do it in either order. Just keep in mind that when it tells you F is similar to G, the 3, whatever comes first here, will refer to whatever comes first in the similar statement. So this would have to be the F. And the 2, the second thing, would be whatever came second. So this would be G. So if I tell you like A is similar to B, and they have a ratio of similitude of 1 to 2, 1 refers to the A, 2 refers to the B, and if I wanted to write this as a proportion, I could write 1 over 2 or 2 over 1. And I'm allowed to write it either way. I just have to keep in mind which one is referring to the pre-image and which one is referring to the image. And that's really the only difference between this and scale factor. As soon as I write it out as 1/2 or 2, I've turned it into what we call our scale factor, or K. And this is just a review from earlier. K tells you what you need to go, or our scale factor K tells you what you need to multiply lengths in your pre-image by in order to get your image lengths. And you can find K by doing an image length divided by your pre-image. And this is going to be a single number, can be a fraction, that's fine, like 1/2 or 2, as opposed to a ratio, which is what we see here, our 3 to 2. Okay, so let's write out the similarity statements and find the ratio of similitude and the scale factor for these. I'm just going to do A. I want you to do B. So for our expansion, if I wanted to write the ratio of similitude and the similarity statement and the scale factor, what I'm going to do is look first at figure A versus figure B. I'm told it's an expansion. That means that I'm going to start small and finish with something that is large. So the pre-image should be small. I should multiply it by K, and I should get my image that's large. The reason why I'm writing this out is because we're going to write our similarity statement, our ratio of similitude and scale factor, and expansion is going to be really important for scale factor. Okay, so a similar statement, this is figure A versus figure B. We know these two things are similar, so I could say A is similar to B, and I'm just getting the A from here and the B from here. Now my ratio of similitude just describes the length between these two, links in common between these two. So here, my proportion that I'm looking at, or ratio that I'm looking at, is I started with a 1.5 and I ended with a 4.5. Now the thing is, we don't really like to stick to fractions like this, or to even stick to things that are not whole numbers when we're talking about these proportions. So I'm going to try to get these into whole numbers and see if I can simplify it from there. So 1.5 to 4.5 would be the same as saying, well, let's just double both of those, 3 to 9, right? And 3 to 9 I could just say as 1 to 3. So for every one length in the first, I'd end up with 3 in the second. There's a quick way of doing this. If you're like, oh, I really struggle to, like, okay, why would I multiply by 2? I'm multiplying by 2 to get rid of the 0.5. Why would you divide both of these by 3? Well, just look at it this way. These are basically fractions, right? So I'm ending up with a fraction that is 1.5 over 4.5. And that's 0.3 repeating. Now, if you don't immediately see this and see 1/3, what you can do is on your calculator, go to math button, hit fraction, and it's going to give you the corresponding fraction. And that, by the way, can be switched back into a ratio of similitude just by replacing the division sign by that colon, so 1 to 3. So you're allowed to use either method here. You can either just divide them and check what it gives you. If it gives you a number like 5 as an answer, you could just do 5 colon 1, and that would tell you it's 5 to 1. Now comes our scale factor, and that is the k that we're going to get. And remember, that's saying take your image, divide it by your pre-image, and that's your k. And since this one over here is my image and this is my pre-image, I'm doing 3 divided by 1 to get k, which is just 3. All right, so I want you guys to try it out with the contraction. Remember that it is a contraction, so your scale factor should be between 0 and 1. Okay, so let's check out our next problem then. If PMT is similar to the triangle ABC and they have a ratio of similitude of 4.5, PM is equal to 14 and CA is equal to 9, we want to find as many other segment lengths as we can. So let's first start by drawing out our triangles. I'm going to do PMT and watch that you line them up just like we did with congruent figures. P corresponds to A, so A needs to be in the same spot. And I'm going to make this one a little bit bigger because I know my second figure, it's a 4 to 5. My second figure is quite a bit larger, at least a little bit larger. A corresponds to P. M corresponds to B because they're in the same spot in my statement, and T corresponds to C. Okay, so now they have a ratio of similitude of 4 to 5. That means that anything in the first one, PMT, would be a length of 4, would change into a length of 5 in ABC. So if I know that PM, this distance, is 14, and I know that CA is 9, I want to find as many other ones as I can. Keep in mind here that what they're saying is I could do 4 over 5 for my ratio of similitude, and 4 is our pre-image, 5 is our image. That means that it sets up the proportion that I need to solve using means extremes. So here, my pre-image length of 14 would be like this 4, because remember, those remain in the same spot. Our pre-image remains in the same spot. And my missing length of AB, I could call X, that's that corresponding length to 14, and I could drop that down here because it should be proportional. That means I can use means extremes to solve it, giving me 4x is equal to 5 times 14. And when I do 5 times 14 and divide that by 4, I get an x value of 17.5. So that means that x, this length here, is 17.5. And I can just relabel that AB. Now let's find the other length. I know that I have this one in my image, not in my pre-image. So if I start with that same proportion, 4:5, and I set it up with my pre-image over my image, this 9 would go on the bottom because it's from the image length. And the missing length would be the corresponding side, or PT, and I'll just call that one Y. Here I can set up means extremes, do 4 times 9 is equal to 5 times Y, and we know that 4 times 9 divided by 5 will then give us our final answer of Y is equal to 7.2, and we would be good to go. You can do the same sort of thing using scale factor. So if we knew that these two figures were similar, B, C, D, E is similar to math, with a scale factor of 5.5, that's our K, and BC is equal to 9 and TH equals 4, we want to find as many other segment lengths as possible. Now the difference here is when it gives you scale factor, you've got to remember that you're working with pre-image times K is equal to image for your formula, okay? So when I have BC, I'm starting with a length in my pre-image, 9. I'm multiplying by my scale factor, 5.5, and I'm ending with my image, which I don't know what that is right now, but I can just do 9 times 5.5, and I end up with 49.5. And that would be the same as the length that corresponds to BC. And since BC are the first two, that would be the length MA. Next, I have, what about TH? Well, TH I can see is something in my image. So if I'm still just mimicking my formula here, that's an image length of 4, which is going to be equal to my scale factor, 5.5, times the pre-image length, which I'm just going to label P. And I can solve for P by doing 4 divided by 5.5, which gives me an answer of 0.7272, so on and so forth, repeated, is equal to that pre-image length. And let's find the name of that pre-image length. T and H correspond to B and D. They're in the same spot. So DE would be equal in measure to 0.727. And those will be the only ones I can find because those are the only two links that have been given to me. And I would be good to go at that point. So today, all you have to do is find that contraction above to show that, hey, I watched this, I have the concept, and ask me questions if you don't have that concept, or if you're not sure what I did with one of these two problems. Tomorrow we're going to do some practice with this, and I'm also going to give you a little bit of a mini project to start on. Have a great day.